In this video, we're looking at ECAA 2020, Section 1, Question 18. So we're told that two vertices of a square are points 1, 1 and 3, 5. So I've just drawn those on a little grid here. And we need to find the differences in the perimeters of the smallest and largest squares that can be made using these 2 points as vertices. So let's start looking with the largest square we can make. We know that these 2 points are 2 different vertices, so that means that our lines here could either be connecting this one across the square or this side at the bottom. Now, which of these two, if our line segment here was making them, would make the largest square? Would actually be this one at the bottom here. If our line was this diagonal, we'd have to make the sides shorter, as this is the longest line. We'd have to make our sides shorter, which would give us a smaller square. So having this line segment as the bottom one, or any of the sides really, this is going to make our large square. Therefore, we know the area, or the perimeter, actually is 4 times the length. It's going to be 4 of our sides. So now we need to find the length of this here. And how can we do that? Well, let's make it into a right angle triangle, because then we can use our Pythagoras. A squared equals b squared plus c squared. So we know that our length here, our c squared, is going to be the square root of the other 2 sides here. And we can work that out using our coordinates. We know it's going to be the square root of 5 minus 1 squared plus 3 minus 1 squared, or 4 squared plus 2 squared, or square rooted, root 20. We can simplify that down to 2 root 5. So that's our length. And all we have to do to find the perimeter is times it by 4 to get us 8 root 5. So now we want our smallest square's perimeter. So I've just labelled the size of our square x, and we know that this line in the middle is going to be this line here. So our shortest length of perimeter is going to be 4x. And how are we going to work out what x is? Well, again, we have another right angle triangle, and this time we know our long hypotenuse here. So using Pythagoras again, and this time we know what our a squared is. It is 2 root 5. We can square that, and our other 2 sides are both x squared. So we can simplify that down to 4 times 5 equals 2x squared, 20 equals 2x squared, x squared equals 10, and so x equals root 10. Therefore, our perimeter is root 10 times 4, or 4 root 10. So we have to find the difference in our perimeters. So we know the largest is 8 root 5, and the smallest is 4 root 10. Our difference, we just have to take them away from each other. So we can simplify this down into root 2 and root 5 to give us 8 root 5 minus 4 root 2 times root 5, and our final answer being 4 root 5 brackets 2 minus root 2. That is our final answer, and so our answer is D.